Good morning, one and all present here. I am going to take introduction to microprocessor. You know very well microprocessor. Millions of integrated circuit interconnected within the chip is called the microprocessor. You know micro means mini. Processor means it can execute the instruction simultaneously. You know different types of processor. GPP, general purpose processor, and then ASIP, application specific instruction set processor, and then third one is combinations of both ASIP and GPP processor. Fourth one is single core processor. Fifth one is dual core processor, and then last one is multi core processor. First one is general purpose processor, the instruction set not designed for particular application. For example, 8085 microprocessor and 8086 microprocessor. What is the main difference between 8085 and 8086 means 8085 microprocessor is 8-bit microprocessor. At a time 8-bit data going to execute. Say, and then 8086 microprocessor is 16-bit microprocessor. At a time it can execute the instruction in 16-bit. And then second one is ASIP. So the instruction set designed for specific application. The best example is DSP, digital signal processor, and microcontroller, 8051 microcontroller. And then third one is combinations of both. Okay, it can use both instruction specific and then not specific. The best example is 8087 coprocessor. And then remaining processor is a more than one instruction, it can execute the instruction simultaneously. Is called dual core processor, multi core processor, and then etc. First, 8086 microprocessor. You know, 8086 microprocessor is 16-bit microprocessor. It can execute the instruction in 16-bit at a time. So 8086 microprocessor is 16-bit data lines D0 to D15 and then 20-bit address lines A0 to A19. Here the data with addresser mixed multiplexed with AD0 to AD16 and then AD17 to AD19. Here 8086 microprocessor, 8086 microprocessor has 20-bit address lines. So 2 to the power of 20 equal to 1 MB memory location used in 8086 microprocessor. Basically, any architecture divided into two types. First one is bus interface unit. Second one is execution unit. You know very well bus interface unit. Okay. How to execute the instruction means first fetch the instruction, decode the instruction, execute the instruction, and store the instruction. Read the instruction from the memory and then decode that instruction and then execute in arithmetic and logical unit, and then it can store again in accumulator register. So 8086 microprocessor architecture basically divided into two types. First one is bus interface unit, second one is execution unit. You know very well execution unit, it can execute the instruction simultaneously. Here execution unit has different blocks. First one, general purpose register. Here 8086 microprocessor has 4 general purpose registers, AX, BX, CX, DX. Each register has 16-bit registers. AX is accumulator register, BX is base register, CX is count register, and DX is data register. Here 8086 microprocessor, it can support 8-bit also. So AX register divided into two 8-bit register, AL and AH, and then base register BX basically divided into two, BL and BH, and then count register basically divided into CL and CH, and then data register basically divided into DL and DH. Each registers divided into two 8-bit registers. AL, AH, BL, BH, CL, CH, and DL, DH. Next registers is stack point register, base point register, source index, and the destination index. This is also 16-bit registers in 8086 microprocessor. Next, arithmetic and logical unit. Here 16-bit arithmetic and logical unit here used. Arithmetic and logical means it can perform arithmetic operation, addition, subtraction, multiplication, division, and inverse multiplication and inverse division, and also logical operation and or XOR, NOR, etc. And then next 8086 microprocessor is flag registers. Flag means easy way to identify the program in current status. Here 8086 microprocessor is 16-bit flag registers. Next, second unit is bus interface unit. It has 4 segment registers: data segment register, stack segment register, code segment register, and extra segment registers. Each segment register has 64 kilobit memory location. You know very well 8086 microprocessors 1 MB memory location. That means 2 to the power of 20 equal to 1 MB memory location. Okay, here the 4 segment register but equally divided into 64 kilobit memory location, and then one more pointer is stack pointer. It can identify the address of next instruction. So again, so 8086 microprocessor, it can support for 5 planing concept by using instruction queue. Here 6 byte of queues used in 8086 microprocessor. It has 4 16-bit register: AX, BX, CX, DX, and CX, and then so each 16-bit divided into 2 8-bit register: AL, AH, BL, BS, CH, CL, and then DL, DH. You know very well, L it's identified by lower order byte, H identified by higher order byte. So this is 8086 microprocessor flag registers. The flag register is 16-bit flag register. Here you know CF carry flag, PF parity flag, AF auxiliary carry flag, ZF zero flag, and then SF sign flag, and then TF trap flag, and then IF inter flag, DF direction flag, and OF overflow flag. Okay, U identified by unused flags. Okay, first one is carry flag. First, carry flag. After calculating arithmetic and logical operation, the result goes to any carry it can set, otherwise it reset. And then second one is parity flag. Okay, parity basically divided into 2 types, and then odd parity and then even parity. If you can take, okay, even parity, after calculating arithmetic and then logical operation, the result goes to even number of ones it can set, otherwise reset. And the next one is auxiliary carry flag. It's only used for BCD arithmetic operations, not used now. And the next one is zero flag. 0. After calculating arithmetic and logical operation, the result goes to all the values goes to 0. The 0 flag goes to set, otherwise reset. Second, next one is SF sign flag. After calculating arithmetic and logical operation, the result goes to any sign. That means negative it can set, otherwise reset. Here trap flag is used for single step error. Okay, it can execute line by line. It's like interpreter, and then interrupt flag it can set. Okay, the microprocessor get interrupt, otherwise the microprocessor it can execute the instruction line by line. And then OF overflow flag. After calculating arithmetic and logical operation, the result goes to too high or too low it can set, otherwise reset. So 8086 microprocessor has 4 segment register. Each segment has 64 kilobit memory location. The segment register is like code segment, data segment, extra segment, and stack segment. You know very well the code segment register. The starting address of code segment register is 348A02 489FFH, and then data segment register starting address is 200002 2FFFH. H is identified by hexadecimal register. And then stack segment register, it's only used for stack operation, push and then pop. Okay, the starting address of stack segment register is 5000002 5FFFH. And extra segment register, last one is extra segment register. The starting address of extra segment register is 7000002 7FFFH. The total number of memory location is 1 MB memory location. The starting address of memory location is 0000002 FFFFF. 20 bit address lines used in 8086 microprocessor. 8086 microprocessor instruction. You know very well instruction. Instruction means command to the system to perform a particular task. For example, do something, move, add, subtract, multiply, div, rotate, rotate right, rotate left, rotate with carry, rotate left with carry, jump not equal, jump equal. So these and all the basic instruction set of 8086 microprocessor. Here 8086 basically instruction set basically divided into two parts. First one is operand part, second one is operation part. Okay, so for example, move ax comma bx. Here move is operand, and then ax comma bx is operand. Operand basically divided into two types. First one is source operand, second one is destination operand. Here move ax comma bx. The meaning of ax comma bx, move bx register data into ax register. Move means this is the move the data from one to another. The move is operations, and then ax comma bx is operands. These are the different types of instruction sets used in 8086 microprocessor: data transfer group, arithmetic and logical group, branch instructional group, loop instructional group, machine control instructional group, flag manipulation instructional group, shift and rotate instructional group, and string instructional group. First one is data transfer group. You know very well data transfer. Transfer the data from one to another. The example of data transfer is move. The examples of data transfer is move ax comma some datas, that is 16-bit datas. Here move ax comma 1234 means move 1234 data, 16-bit data into AX register. Okay, you know very well 8086 microprocessor, it can support 8-bit also. Okay, here using 8-bit instruction means move AL comma 08 data move into AL register. Here AL supported for 8-bit register, and then AX divided into two 8-bit register, AL and AX. So the important data transfer is move the data from one to another, or move the data from source to destination instructions. Okay, and then next different types of data transfer is increment, decrement, etc. And then second one is arithmetic and logical instructional group. Arithmetic instruction group, the examples of arithmetic means addition, subtraction, multiplication and division. Logical means and, or, XOR, NOR, etc. For example, arithmetic instruction, arithmetic you can write ADD, add. Okay, subtraction means SUB, subtract, and then multiplication MUL, and then division DIV. Can use like this only. So for example, addition of two numbers, addition of two 16-bit numbers means you can write like this: add ADD, add AX comma 1234. Now you can assume AX value in 16-bit. Okay, 2354. Now 1234 and 2354 you can add with accumulator, and then store the result stored in accumulator register. So okay, same thing only. Arithmetic with addition with carry means you can write ADC, that is called add with carry. Okay, and then logical like this. Okay, logical it can perform addition and, or, XOR, NOR. And means AND or OR, and then XOR XOR like this you can write. Okay, logical instruction like this. And then third one is branch instructional group. Branches different types. Okay, jump, call, return. Okay, this and all. Okay, branch instructional group. And then loop basically divided into two, absolutely and then long. Okay, and then fifth one is machine control instructional group. It can controlled by machine. The examples of machine instructional group is no operation, NOP, halt, stop the program, HLT, wait sometime, it can use WAIT, wait, and then lock the 8086 microprocessor, you can use LOCK. Sleep in 8086 microprocessor. Yes, next flag flag manipulation instruction, it can use only string manipulation, that is moves string MOVS and compass CMPS like this instruction. It's a same both the same in flag instruction and then string instruction. And the last one is shift and rotate instructional group. Shift has 4 types, rotation has 4 types. Shift rotate, shift left, shift left, shift right, shift left with carry, shift right with carry. Same in rotation also, rotate left, rotate right, rotate left with carry, rotate right with carry. The examples of instruction is SHR, shift right, SHL, shift left, SLC, shift left with carry, SRC, shift right with carry. Same in rotation, ROR, rotate right, ROL, rotate left, RLC, rotate right with rotate left with carry, RRC, rotate right with carry. These are the examples of data. These are examples of instruction set, data instructional group. For example, move CX, 037A, that is 037A is 16-bit register. Why means A 4-bit, 7 4-bit, 3 4-bit and then 0 4-bit. The total number of bits is 16. This 037A data directly move into CX register. And then second, okay, this is data this data transfer group, and then second one is move AL, BX. This also okay 8-bit register. You know very well 8086 microprocessor, it can support both 16-bit and then 8-bit also. So first example is 16-bit architecture, and then second example is 8-bit architecture. Here BL register data move into AL register. You know very well AX is 16-bit register. The AX divided into 2 8-bit register AL and AH. BX basically divided into 2 8-bit register BL and BH. That's why we are using lower order byte BL register data into AL register, the 8-bit register example.